Hello everyone and welcome back to yet another edition of the Calsoft Podcast, your premier source for discussions on all things tech. I'm your host Shantanu Pant and with me today is Akshay Chandelkar. Hi Akshay.
Hello.
Welcome to the show Akshay. So before we start, a quick introduction. Akshay has been working in QA for the past 15 years. He's got a wealth of practical experience and he's worked on storage and data protection products like Pillar Data, Veritas Netbackup, and even Qlogic FC. Now, thanks to his work on these products as well as his experience working on converged network adapters and HCI, he is uniquely qualified to talk about today's topic, SMB Characterization. So, Akshay, this is a fairly obscure topic. Could you explain to us a little bit about what exactly is workload characterization?
Workload characterization is the process to design different I/O patterns based on various factors to meet the performance SLAs identified for an application or system under test. So workload characterization also includes different types of workloads, I/O patterns, SLAs, and tools depending on the use cases identified for the application or system under test.
I see. Pretty technical. So, could you take us a little bit deeper into this? Like, what are the factors that define the characteristics of the average workload?
So there are multiple factors that define characteristics of the workload. To start with, the first factor is I/O size. That is the size of an I/O request, typically expressed in bytes, kilobytes, or megabytes. Then it's IOPS, that is number of I/O operations per second. So IOPS basically is a combination of reads or writes per second. So there are R IOPS, which actually stand for read IOPS, and write IOPS, which stand for writes per second. The next factor is throughput, which measures the amount of work performed in a given time. That's IOPS into I/O size is equivalent to throughput. Then it is response time, the time required to send, process, and receive acknowledgement for a given request. A read request involves sending a request for data processing time to retrieve the data and returning the data payload. Whereas a write request involves sending a data payload, the processing time to store the data, and returning confirmation that the write has completed. The size of an I/O request impacts how long it takes to process a read request or a write request. Then there is a read-write ratio. So how many requests are read compared to writes? The read-write ratio is important because in most cases there is less effort required to process reads than to process writes. And the last but not the least factor is random versus sequential. So sequential I/O is basically a sequence of requests accessing data blocks that are adjacent to each other, whereas a random I/O is the opposite, a sequence of requests that are not adjacent to each other and may not have any regular pattern.
Okay, so this is a pretty good primer of all the factors that go into it. But now let's get into the meat of the topic. Can you explain SMB and NFS protocols to our listeners?
I'll give you a brief about both the protocols so the listeners have a fair idea what these protocols are. So SMB is in computer networking server message block, one version of which is also known as Common Internet File System, which is CIFS. It's a communication protocol for providing shared access to files, printers, serial ports between nodes on a network. SMB also provides an authenticated inter-process communication mechanism. Most usage of SMB involves computers running Microsoft Windows. Now, NFS is a network file system. It's a distributed file system protocol originally developed by Sun Microsystems. It allows a user on a client computer to access files over a computer network, much like local storage is accessed. NFS, like many other protocols, builds on the open network computing remote procedure call systems. So here is a brief introduction about SMB and NFS protocol.
I see. So based on what you've said, all of this has it's been developed over a pretty long time, and not a lot of people know about it. So how exactly has it grown? Like, I'm pretty sure the SMB version 1 was, definitely not as advanced as it is today. Can you walk us through the evolution of these systems?
Yes, both SME and NFS have evolved over a period of time, and there have been different versions, and these versions have different performance enhancements. So I would like to explain a bit about SMB first and then NFS. So SMB version 1, basically extremely chatter protocol, hence becomes very slow on WAN as the back and forth handshake of the protocol magnifies the inherent high latency of such networks. And the second is 16-bit data size. This limits the maximum block size to 64K. So in SMBv2, there were some performance enhancements like reduced chattiness. So by reducing the number of commands and subcommands from over 100, about 19. The next thing was pipelining, like sending additional requests before the response to a previous request arrives, thereby improving performance over high latency links. Third improvement was ability to compound multiple actions into a single request. This significantly reduces the number of round trips the client needs to make to the server. Then there are durable file handles, allows connection to an SMB server to survive brief network outages. Then it supports symbolic links, then caching of file properties, better scalability like increased number of users, shares, and open file per server. And then there is 32 or 64-bit wide storage fields. So this removes the previous constraint of SMBv1 on block size, which improves performance with large file transfers over a fast network. Then there was the next version that came in was v2.1. It had more performance enhancements and opportunistic locking mechanism. And then latest one is version 3, which has several significant changes intended to add functionality and improve SMB v2 performance, notably in the virtualized data centers. Then it has SMB direct protocol, which is SMB over RDMA, then SMB multi-channel, and SMB transparent failover. So these have been the version over version performance enhancements with regards to SMB. Now I'll talk a little about NFS as well. So NFS version v2 is operated only over UDP, and it has only synchronous writes. So in the version 3, there were improvements like support for 64-bit file sizes and offsets to handle files larger than 2 gig, support for asynchronous writes on the server to improve write performance, then additional file attributes in many replies to avoid the need to refetch them. And then there was read a directory plus operation to get file handles and attributes along with file names when scanning a directory. And then the latest NFS version is v4, which support to take advantage of clustered server deployments, including the ability to provide scalable parallel access to files distributed among multiple servers like PNFS extensions. And there are sessions, and directory delegation and notifications, multiple server namespace, and access control lists and discretionary access control. So these have been the enhancements, performance enhancement, version over version in NFS.
So it looks like these systems have been growing quite a bit and they've matched up to current technology quite well. So these are very complex topics. So let's just take a look at how exactly what kinds of things they're used for. Yeah, what are the different use cases that fall under SMB or NFS characterization?
Yeah, there are a lot of use cases that qualify for the SMB NFS characterization. But for today's topic, we would just curtail it to about 4, which is archival, then video streaming, VDI, and big data.
Okay, those are quite relevant. I mean, pretty much all of us use at least one of these in our day-to-day lives. Like, I definitely use video streaming from Netflix every day. So, So yeah, let's start with archival, shall we? What are the types of workloads for this use case?
So Archival has different types of workloads. First is sustained workload. It's activity or a level of performance that is maintained for several minutes or hours. Then you have average workload. So a workload average typically represents the arithmetic mean for a set of values over a known time. And the third type of workload is peak and burst. It's like a workload peak represents the highest level of performance achieved by an application, device, or infrastructure during a sustained period of time.
I see. So what kind of IO pattern is used for this?
So for archival use case, the generic IO pattern is sequential read, write.
I see. So in that case, I assume that it's so that file integrity is maintained. Yeah.
That's right.
Right. What kind of SLAs are used for archival?
So the SLAs for archival use cases are first is consistent streams of read-write operations. And second is data accuracy or data integrity.
Right. So if somebody is, planning to work on archival, what kind of tools would they use?
Yeah, for archival use cases, if you have to characterize the workloads, the general tools are basically synthetic IO tools like IO meter, FIO, and IOZone.
I see. I see. All right. Let's pivot to video streaming then. What are the types of workloads that sites like, say, YouTube or Netflix would use?
Yeah, so for a video streaming use case, there would be different types of workloads as compared to the archival use case. The first would be static workloads. So these are the workloads where the resource utilization is pretty known. There are no surprises, no traffic spikes and stuff like surveillance cameras. The next workload is periodic workloads. These workloads have utilization at specific times, example, motion sensors or video games. The third is unpredictable workloads. These workloads include popular apps like social networks, online multiplayer games, game streaming apps, and more. And the last is hybrid workloads, workload that can be a hybrid of all the above three, like the static or periodic or unpredictable workloads.
I see. So, what kind of IO pattern does video streaming use?
So video streaming would generally use sequential write and a random read as an IO pattern.
I see. So, like in that sense, it will be probably best used for, say, watching a video in its entirety or skipping to random sections. Is that how that works?
Correct. Yeah, that's how it would generally work.
Makes sense. So, what kind of SLAs are important for video streaming?
So the SLAs that are relevant for video streaming are first is low latency, second is high performance of read-write operations.
Makes sense. Makes sense. And if I were to, decide to go into video streaming characterization, what kind of tools would I be using?
So the industry-wide use tool for video streaming use case is VDBench. It covers most of these workloads that we just talked about.
I see. Okay. Let's move to the third topic you had mentioned, VDI, right?
That's right.
Yeah. What kind of workloads does VDI require?
So VDI has a similar kind of workload as we discussed in archival, so which is sustained workload, as we mentioned, that is maintained for several minutes or hours, is known as sustained workload. Then you have average workload, typically represents the arithmetic mean, and then it is peak and burst, which is peak represents the highest level of performance achieved by an application or infrastructure during a period of time.
I see. And in case of VDI, what's the IO pattern that's generally used?
So in a virtual desktop infrastructure environment, general IO pattern would be random read, right?
Yeah. So like, so you've got full freedom of usage. Yeah, makes sense. Makes sense. So what kind of SLAs are ideal for VDI?
So the SLAs that are relevant for VDI are first is low latency, second is high performance of read-write operations, and third is data consistency.
Makes sense. Makes sense. And like to cap it off, what kind of tools would I be needing if I were to go into VDI?
Yeah. So VDI would have we could use different kinds of tools like Login VSI, VMmark, or FIO to have the workload characterization for VDI use.
I see. All right. Then in that case, let's get to, quite frankly, the section that I think most of our listeners will be waiting for, big data. So, like, given how important big data is, and given that SMB characterization or NFS characterization has a pretty major impact on your big data, what types of workloads, fit?
Yeah. So, as you know, big data is a huge area. So there are different workloads. I'll try to talk about quite a few. I'm sure I might not be able to cover all of them, but I'll talk about quite a few that qualify as the workloads for the big data use case. The first one is sync, sense, and response. So batch incoming event streams with predefined behavioral patterns and instantaneous response after observing signatures in real time. The second is high velocity inserts. So it's a unique workload while ingesting terabytes of sensor and machine generated data. These are inserted only workloads without an update or lookup workloads. The third is very large graph traversal, a pattern for finding interrelationship among nodes in a network. And this workload is computational and read intensive. Fourth is needle in a haystack. It's like searching a string or attribute from the huge data sets across multiple attributes. It's a most common pattern in machine data use cases. Fifth is event stream and measure. So collecting discrete periodically occurring event across multiple events. Sixth is text indexing while processing semi-structured data tools like using needs to index the strings. Seventh is moving window event absence. It helps cases where finding the absence of events across moving time window. Then the eighth workload is type of workload would be concurrent inserts and updates. It's like pattern to collect unstructured data ingestion by thousands of users across the world, or update or insert based on events like booking, gaming, and so on. Ninth is unstructured data ingestion, like bringing unstructured data into common repositories to analyze and yield previously untapped intelligence. This is one of the most common use cases for big data. And then there is sequence analysis, which is pattern helps to examine trends that can form a story reading problem context from periodic chunk of events. And the last type of workload would be unpredictable chain of thoughts. It's like discovering new patterns of data with questions previously not thought of. So this is about 10, 11 different types of workloads that would be used to characterize the big data use.
Man, SMB characterization, it's honestly a really flexible field. Like, in terms of big data, it's got more workloads than all the other three use cases combined. Yeah. So, what kind of I/O pattern would be used in big data?
So big data, most of the, as we spoke about all these different types of workloads, the most used I/O pattern would be unstructured data.
Yeah, makes sense given the absolutely massive data sets. What kind of SLAs would be used in this case?
The SLAs for a big data use case is generally rate of data ingestions and retrievals.
Oh, all right, all right. And well, I'm not personally going to go into big data, but I'm certain some of our audience might. So, what kind of tools are best used for this?
So the best tool available in the market to cover all these different types of workloads, I would say, is JMeter. that qualifies for most of these workload types.
I see. So, given how important these kinds of characterizations are, I would take it as a safe assumption that testing them to make sure that they work properly is vital. What, according to you, is the ideal test environment?
So the ideal test environment depends on multiple factors. One is study the application or system and the test thoroughly to characterize the workloads. Second is simulate high, low latency scenarios for the network subsystem. Third would be simulate error injection scenarios for a storage subsystem. Test environment to support different configurations, and fifth would be compare the performance numbers for different configurations.
I see. I mean, this seems fairly doable. Honestly, this is a very deep and complicated topic, and I am sure that we would love to hear more. Unfortunately, I think that's all the time we have for today. SMB characterization seems like the kind of technology that's going to change things a lot, but in a very subtle way. Seems like the kind of thing tech leaders should be keeping an eye on, if you ask me. Well, Akshay, thank you so much for being a part of this conversation, and I hope to see you on this podcast again soon.
Thank you, Shantanu.
Well, this has been the Calsoft Podcast featuring Akshay Chandelkar. This was a fascinating look into SMB characterization and seems like the kind of tech that most companies will be needing soon enough. Stay tuned for future podcasts where we explore the latest tech concepts and advancements. Thank you for listening.